In this problem in Pythagoras' theorem, fractions are involved. The question is, find the shortest side of a right-angled triangle with a hypotenuse of 5 and one side 1.5. Now the diagram's been drawn for us. Here we go, hypotenuse 5 centimetres and labelled as C. One side 1.5, labelled as A. And the unknown side, the side we want to find, is being labelled as B. Now I'm going to do this one in two ways. One where we use our knowledge of fractions, and the other one where we escape using the ideas of fractions by using our graphics calculator. Firstly, let's do it using our knowledge of fractions. Pythagoras' theorem says the sum of the squares of the shorter two sides is the longer side squared. So substituting, A is 1.5, C is 5, and B is what we want to know. So this is what it looks like. 1.5 squared plus B squared is 5 squared. Now, if we want to square 1.5, first of all we have to think of that as an improper fraction. 1.5 is 3 halves, isn't it? Or 1 2's are 2 and 1 is 3. 3 halves squared plus B squared is 5 squared. Now let's think about this. 3 halves squared. Well, that means 3 halves times 3 halves. And we know when we multiply, after we've done our cancelling, and there's none here, we multiply the numerators out, 3 3's are 9, and we multiply the denominators, 2 2's are 4. So 3 halves squared is the same as 9 over 4. So this becomes 9 over 4 plus B squared is, and 5 squared is 25. Now to solve for B, we need to take 9 over 4 from both sides, so it becomes B squared is 25, take 9 over 4. Now we have a subtraction involving fractions, and one way to do that is to write the 25 with denominator 4. We'll do that up here. 25 times 4 over 4 will express 25 as 100 over 4, and then we need to take 9 over 4. So B squared is 100 over 4, 25 is 100 fourths, take 9 fourths, so B squared is 91 fourths. Taking the square root of both sides and just looking at the positive one because it's the length of a side. B is the square root of 91 over 4, which is the square root of 91 divided by the square root of 4. And the square root of 4 we know is 2. So B is just the square root of 91 over 2 centimetres as an exact answer. We could change this to a decimal if we wanted to get a decimal approximation for the length of the side B. There's one way to do it. Second method, we're going to use our graphics calculator. Diagram drawn again. Again, we'll write down Pythagoras' theorem and substitute. 1.5 squared plus B squared is 5 squared, but this time rather than working with the 1.5 squared, we'll make B the subject. So we're going to take 1.5 squared from both sides. So B squared is 5 squared, take 1.5 squared. So B will be the square root of the right hand side, which is this. Now we can work this out directly on our calculator. First of all, we could work out what's under the square root sign. So let's get our calculator, work it out in maths mode. 5 squared take, now we want a fraction, so we're going to do shift and the fraction button, fill in the parts, the whole number part, move on, fill in the numerator, move on, fill in the denominator, move on, and square that fraction, and then evaluate it. That is the evaluation of what's under the square root sign. And now we can work out that the square root of our previous answer is, now on my calculator this came up as a decimal. B is 4.79696, etc., etc. On your calculator it should come up in what we call surd form, like this. B is the square root of 91 over 2, the exact answer in centimetres that we had using the previous method. You can see that using this method, if you're careful using your calculator, you can